Okay, look at number 1 at the top of 158. It says Anna Marie's heart beats 225 times in 3 minutes. How many times does her heart beat per minute? Remember when we do ratios, you have a first term to a second term. So what 2 things are we looking at in this problem?
First term and second term.
But what 2 exact things are we looking at in this problem number 1?
A ratio.
Look at number 1 at the page of 158.
Oh, 225 in 3 minutes.
Okay, so what does the 225 stand for?
Her heartbeat.
Yeah, how many times her heart beats
Per minute.
in how many minutes?
3 minutes.
3 minutes.
Oh, and
Okay?
time.
But I want to know how many beats will there be in 1 minute?
75.
So cross multiplication says go 1 times 225 divided by 3 is 75 beats per minute. Now, when you set these up, you have to make sure that your terms that are alike go across from each other. So beats need to go with beats and minutes need to go with minutes. The next one says a nickel has a mass of 5 grams and a volume of approximately 689 thousandths centimeters cubed. What is the approximate density of the nickel? Okay, so we have 2 terms. When we talk about density, we talk about the first term has to be what? Mass over volume. So you just line it up. What information do I have? The mass of the nickel is 5 grams. What is the volume? 689 centimeters cubed, which is label for volume. We need to do a unit rate. So we're going to go 1 times 5 is 5. Divided by 689 thousandths is 7 and something.
7.256.
Okay, round to the nearest hundredth.
7.2.
6 grams per centimeter cubed is the density of the nickel. Okay, the next one says a bicyclist rides the first 60 kilometers of a 220 kilometer race in 1.5 hours. What is the bicyclist's average speed? So speed is always distance over time. So how far does he go?
60 kilometers.
Okay, he goes 60 kilometers in 1.5 hours. So we're going to do a unit rate. We want our second term to be 1. In 1 hour, how far does he go? Go 60 divided by 1.5 is? 40 kilometers. So you would say his average speed for the first part of the race is 40 kilometers per hour. Okay, that's for the first part. The second part says a reporter estimates.
It'd just be 40.
He went 40 kilometers an hour, like in 1 hour.
Yes,
Per hour.
per hour.
He was going that fast on a bicycle?
Okay, now that's for the first part. The second part says a reporter estimates that at this speed, the bicyclist will finish the entire race in less than 6 hours. Is this reporter's estimate reasonable? So if he's going to go 40 kilometers per hour and the whole race is 220 kilometers, will he finish in 6 hours or less?
Yes.
Yeah.
5.5 hours.
Okay, how did you calculate that?
220 divided by 40.
Okay, so you went 220 divided by 40, and you get what? 5.5 hours. So will he finish in less than 6 hours? You would say yes because, no, you would say yes because 5.5 is less than 6. He would finish in 5.5 hours. Number 4, a 16-ounce box of crackers costs $3.99. $6.99, which is the better buy. Okay, you need to set the problem up. When we talk about unit rate, when we're buying something, you put dollars over the weight or per unit. and then calculate what it would be for a unit rate. So for this box of crackers, how much would it cost per ounce?
So at least $3.99 divided by 16.
Okay, $3.99 divided by 16.
It'd be $2. Oh no, it's
24 cents.
25. You got it round.
Round to the nearest hundredth.
So be it.
The next one is $6.99 for 38 ounce. How much would each ounce cost? 82 cents?
18. Yeah.
18 cents? Okay, which one's the better buy?
Oh,
$6.99 for 32 ounces.
So you would write your answer as $6.99 for 38 ounces is the better buy. Okay, number 5. Kenji earns $32 in 4 hours. How much does he earn per hour? What's his hourly rate?
Oh, $8.
Yep, because you just go 1 times 32 divided by 4 is, he's making $8 an hour. Okay, let's skip down and do number 7. In 1860 and 1861, riders of the Pony Express delivered mail on horseback from St. Joseph, Missouri to Sacramento, California. The trip was 1,966 miles, and it took about 10 days, or 240 hours. What is the rider's average speed to the nearest tenth of a mile per hour? Okay, so we want our label to be in what? Miles per hour.
8.1.
Okay, set up your problem. How many total miles was it?
200. No, that's
It's
240.
1,966.
Yeah, that number.
And how long did it take in hours?
40 hours.
240 hours.
So it's 196.
1,966 divided by,
240.
which is?
8.1916.
8.19. You're supposed to find the net.
Yeah, 19?
That's what we said. We said 8.1.
Okay. Now, that's the first part. Ladies and gentlemen, a student estimates that it would take a Pony Express rider less than 6 hours to travel 75 miles. Is this student's estimate reasonable?
No.
Why? How would you figure it out?
You'd put
8
it,
times 7 is only that one number, like 54.
Right, so you go 8.19 times
7
how much time he had. How far could he travel?
hours. He, 8.19 times 6. He only traveled 49 miles.
Unless he was going.
So you would say no, in 6 hours he would only travel 49 miles, which is not enough to travel the 75 miles. Okay.
That'd be long.
Now, if you guys are doing a problem like this and you don't know if you're supposed to multiply or divide, I want to show you how you can set your problems up with proportions so that you can solve for the unit that you want. Okay, I know that I'm solving for miles because I want to know how far he will go in 6 hours. So when I set this up, I want my miles to be on top for my first term. Here's my speed, 8 and 1900ths miles per hour. Okay, I want miles by itself. If I put 6 hours up here and just place it over 1 because it will not affect the value of my 6, you know that on cross multiplying, if your units are across from each other, what do? They cancel each other out. What is the only unit that I have left? The miles, units. I'm just looking at units first. I am left with miles, which is what I want. Now I have my problem set up the way that I want it to be set up. I just have to go 8 and 1900ths times 6, which is 49, and then 1 times 1 is 1. And then when you simplify it, 49 divided by 1 is just 49. Okay? Some of you can probably visualize whether or not you need to divide or multiply, but when you start getting into problems where you have 3 or 4 different units that you have to take care of and you don't know if you're dividing or multiplying, if you know what units you want as your answer, you can use your proportions by flipping them, depending on what unit you want for your answer. It has to be on top by itself by the time you're done. All your other units will cancel each other out. If you just line up your units in this way, you have set up your problem so you don't even have to worry about if you're dividing or multiplying, because your numbers will go where they need to go. Okay, and I'll do more. It's called dimensional analysis is what this is called. We'll do more problems later on when the problems get harder, and I'll show you how this works.